Hello everyone. In this session, I'm going to discuss about the Pascal's law in fluid power systems. The Pascal's law that is stated in the fluid mechanics also, and its modified form used in the fluid power systems. That is called as the multiplication of forces. Here, the force is multiplied according to the Pascal's law and distribution of the forces, and that I am going to explain here. That Pascal's law reveals the basic principle of how the fluid power systems perform useful work. This law can be stated as follows. The statement of the Pascal's law is that pressure applied to a confined fluid, the confined means in the restricted space, the fluid whatever is there. Okay, the pressure applied to that fluid is transmitted, that will transmit undiminished. Undiminished means without any loss, without any uh, reduction, without any waste, that in all directions. Okay, that whatever the pressure is there, that will apply to confined fluid, transmit undiminished in all directions throughout the fluid. Throughout the fluid, that will be transmitted and acts perpendicular to the surface. And that will be acts perpendicular to the surface in contact with the fluid. And where the surface which is coming contact with that fluid, perpendicular to that, it will acts. An explanation about this we can take the pressure applied to this statement of the Pascal's law, that the pressure applied to a confined fluid is transmitted undiminished in all directions throughout the fluid and acts perpendicular to the surface in contact with the fluid. Here, the explanation that whatever the Pascal's law is there, the figure shows the how Pascal's law can be applied to produce useful and amplified force. Here, our intention is that the input force we are going to apply, that is a lesser one. Output we should get the more. Okay, that is pressure applied to a confined fluid. This is a confined fluid. Okay, that is in a restricted place, a confined fluid. Okay, transmits the power pressure undiminished. It will transmit the pressure undiminished and acts perpendicular to the surfaces which come in contact with that fluid. Okay, here we are going to apply the input force, and here the pressure, the force per area, that force pressure will be created, and that pressure will be distributes this throughout the fluid, and here the area will be more. Therefore, the force whatever acting on that area, that will be increases, and the pressure on that one, it will be increases. And the calculation we are going to take that by the equation. The force is the P1 into A1. The area is smaller, this one. Therefore, the force applied, we are going to get the smaller with the area. The area is in the second position, that is a 10 times more than that one. Therefore, that area we are going to multiply it with that force. Therefore, here the F2 whatever is there, that is a P2A2. Okay, 10 times the force. Here we can amplify the force, and that amplified force we are going to utilize in the hydraulics for performing the many of the work. Best example of this one, the hydraulic jack. Whatever the example shown here, that is the hydraulic jack. By applying the small force, we are going to get the 10 times more the force in the upward direction at the other places where the area is 10 times more. If you increase the area, and according to that Pascal's law, we are going to get the 10 times force, and that will lift the this whatever the heavy loads are there. And that amplification, how is there? The calculation we can take by using this one. Examples. Consider an input force of 10 Newton. Here the force we are using the 10 Newton is applied to 1 meter square area. This area is the 1 meter square area. Then the pressure P1 whatever is there, that is equal to 10 by 1. Okay, that is a 10 Newton per meter square. The pressure will be acting at this point. Then this develops 10 Newton per meter square pressure and throughout the oil within the housing. Okay, this will develop a 10 Newton per meter square pressure throughout the fluid within the housing. This 10 meter per Newton per meter square acts on the 10 meter square. Here the 10 Newton per meter square, the pressure will be acting on the 10 meter square area, and piston producing a 100 Newton output force. Therefore, it will producing a 100 Newton force. The 10 times more force it will be producing. And this output force performs useful work as it lifts the 100 Newton weight, as it will be lifting the 100 Newton weight. And that calculation according to the Pascal's law of how we can know that one, the P1 equal to P2. That is F1 by A1 is equal to F2 by A2. His F1 is 10 and this F2 by A1 is 1. F2 we need to calculate. This is a 10. Therefore, the calculation F2 is equal to 100 Newton. By applying the smaller force, we can get the larger force by the variation of the its area. And that is the basic principle of the hydraulics, where we are going to amplify the force and do the various uh, different works which are requires heavy loadings. Okay, that further we are going to apply for the different applications this law, and we are going to uh, calculate that whatever the load carrying capacity and other whatever the parameters are required. Thanks for watching. If you like, share, subscribe and comment.